Welcome everyone. So in this video we are going to see about randomized layer Testbench in the system Verilog. So this is the architecture of randomized layer Testbench. So where we have different elements transaction, generator, driver, monitor, agent, scoreboard, environment, test, and top. So these are the different system elements in the randomized layer test bench. So the transaction is nothing but a transaction class helps with top level executions. It provides the important information to coverage model about the generated stimulus. So the transaction class also helps to define activities generated by the agent. It drives it to the DUT and returns back to the driver. So when you see here, it is driver is connected with the DUT. All activities are covered under the transaction class. So that is the main purpose of transaction. Generator is will generate the stimulus required for the design under test. The stimulus is sent to DUT via driver. So you can see in the diagram. Thus, the data is first received by the class driver. The exchange of data from one class to another class can be done using mailbox or queue, that is parallel execution. Now the stimulus generation can be manipulated as per the needs of the verification engineer. The stimulus can be generated based on the needs. It can be constrained, specific randomized generation, or a simple direct testing. And also, it can be automated or manual, but the key benefit is that the verification engineer has the controllability from the test case. The verification engineer can also use assertions uh, for the generator. So driver, it is nothing but will drive the stimulus to the DUT. It receives the data from the generator via mailbox or queue. Next, it converts the data in the form of inputs to the DUT and passes it on to the DUT. The monitor class observes the activity on the interface signal. Once the information received from the signals of the DUT, they are passed on to the scoreboard. So the monitor class also reports the transaction failures and converts the outputs from the DUT to a transaction level abstraction scoreboard. So what is the scoreboard is? It is a scoreboard is where the comparison takes place. Expected data and actual data are compared here. So when you look at here the scoreboard, so it is connected with the input agent and the output agent. So since the data paths for both the DUT and the reference model will be different, the output receiving time for the data could be different too. Hence, the data needs to be stored. Synchronization needs to be set between the expected output and the actual output. Once everything is synced, both outputs can be compared to figure out whether the effectiveness exists. So the environment is where the class instances are presented along with their connectivity. So now on top of the execution of verification using OOPS concept, the system Verilog also offers functional coverage that we will see in different videos. You can say that the all the test cases have been covered when you have 100% functional coverage. Code coverage tells us about the result which achieved from the test cases generated from the stimulus. So these are the architecture of randomized layered test bench. Thank you.